And these slides should look familiar because we last looked at them about 2 days ago, right? So just to recap, what is programming? And here's where these bullets may apply a little bit more strictly than they have with HTML and CSS over the past 2 days. So the first part is still that programming is mostly concerned with transforming input into output. When we start writing JavaScript, one of the things that you'll notice quite a lot is us actually creating values and then moving them back and forth in order to figure out new values. So if for example I'm trying to design a calculator application, well, the values I'm creating then will be the numbers, and the goal of my functions would be then to be able to add or subtract those numbers together, and then the output would be the final result. And that's pretty much the archetype for most of the functions that we'll be dealing with when it comes to our section on JavaScript. It's all about taking information, doing something with it, and then giving back the final value or the resulting value. More than anything, programming is about making logical decisions and repetition. And so in that vein, it's also, once again, I can't harp on this enough, it's very important that from here on out, we're even more clear than we usually are about what it is that we're trying to do and how we think the code is actually operating. And then last but not least, we want to be creative and we want to be able to collaborate with each other. In JavaScript, you'll be solving more complex problems. And so in that vein, it's really important that we not only just get to the right answer, but that we're able to articulate and explain with each other kind of how we got there and what our approach is. And more often than not, you'll discover that multiple approaches work for the same problem. So one of the things that people think when they first start programming is that, oh great, I'm going to spend most of my time cranking out new code. But the reality is when it comes to programming, especially in larger companies or for more complex applications, the code writing part of it is actually not the most difficult part. If you think about something like Facebook, right? And if I wanted, for example, if someone said, hey, David, can you add in the new like feature to Facebook? How that project will most likely break down is I will actually probably spend almost half of my time just not writing new code, but reading the existing code to understand how my code fits into it. And that's critically important because if I write bad code for my like feature, the best case scenario will be that my feature doesn't work. The worst case scenario will be I actually break the entire I actually break Facebook, right? I break part of the pages, I break part of other functionalities, etc. And so whenever you write new code, it's so important that we at least look at the code and understand how it's supposed to fit in with the rest of the pre-existing code first. Once we know that, then we actually need to start thinking about how we want to solve this problem. The analogy I always give is before someone builds a house, they always drop a diagram, right, or a blueprint of how they want the house to look. They'll just start nailing boards to random other boards and hope that by the end of it, you create a full house. And so in that vein, when it comes to programming, it's also very important before we even start writing code that we at least agree and are clear on our approach to the problem. How are we going to create variables? How are we going to calculate the values? And most importantly, how are we actually going to be able to kind of get to the end result? Right? How do we make sure that we end up where we want to be? And believe it or not, this is actually a part where most beginners tend to really kind of, I guess they skip over this process, and the approach that they take is more like, let me just start coding and hope that the right answer kind of pops out of it, which is sometimes may work, but most times it won't. Once you know what your approach is, or once you've determined your plan and kind of determined the blueprint for the code, you actually write the code. And I would say that this part usually takes no more than 20 to 25% of your actual time coding. The rest of the time then becomes spent on testing and debugging code. That is, when you write anything complex, more often than not, the first time you run it, it won't work. And in fact, as a programmer, if you do this more and more, you actually become increasingly suspicious when your code starts working on the first try. So debugging and testing the code is actually a pretty big component of programming, and it's definitely the part where I would say that in general, people spend most of their time when it comes to validating that their code works, right? Writing new code is actually not that bad, but the last 5% of making sure that it works correctly in all scenarios, that's the part that can be quite tedious. And so before we even start writing code then, like I said earlier, we actually want to make sure that we're clear on our approach to the code. That is, we know how we're going to solve the problem, right? And we don't just start writing code from scratch. We don't start writing code from scratch without a plan in place. So hence, we're going to talk about something called pseudocode. Pseudocode is not a language or anything. It's just a term, right? It's code-like. And what it means is it's a way for us to start thinking about how do we actually want to solve this problem? And to do that, we need to answer a few questions. The first one is, what is the purpose of the program? That is, what are we actually trying to accomplish at the end of the day? And then secondly is, how will our program be structured? Or how will the program actually get us there? And so if I say, for example, I want to design an app that will text me if there's a chance that will text me if there's a chance of rain before I go to work every morning. Well, there's a problem. That's a problem that's kind of ambiguous. And I actually need to determine before I start writing any code how I actually want the app to operate. Similarly, if I want to create an app that helps me keep in touch with close friends, once again, the problem is there, but I need to be more clear about how I'm going to design my code to solve that problem before I start writing any code. And so pseudocode essentially is a set of informal instructions that describe how the code is supposed to work. For now, think of this as more of a practice or more of something to kind of get you off the ground, like the extra wheels on a tricycle, right? The plan here is not that you do this every single time, but we do want you to start training and developing this sense of before you start writing code, how are you actually thinking about problem solving? So let's take a look at an example. If I wanted to create a robot, or rather, if I've created a robot and I want that robot to make coffee for me, well, if this robot was a person or like a barista, I would tell them, hey, can you make me a cup of coffee? But to a robot, those instructions aren't good enough. We need to be a little bit more clear. And so one way for us to think about designing the instructions and for our coffee making robot will be to actually create a program, but we need to be very explicit in our directions to the robot. So here's an example of just some of the steps that we need to do to tell the robot how to make the coffee, right? Make coffee by itself is not enough. We actually need to break it down into simpler and more clear instructions. The first one is locate where the coffee maker is in the kitchen, fill up with water, pour the water, ... You can read all of these, right? But the plan is just that we don't just go from step 0 to step 10 all in one go and say, great robot, make coffee. We actually need to kind of break it down into smaller and smaller steps that make it easier and very clear to the robot how to do this. And this is pretty much what we need to do with our code too. Remember, computer programming cannot handle ambiguity, right? Don't ever assume that the computer will just figure it out, because it won't. It needs you to tell it at every single juncture, and very quite explicitly, what exactly you needed to be doing. So in this case, if I tell this robot, do you mind cleaning these 4 squares for me? If assuming this robot is let's say a carpet cleaning robot and there's dirt in every square, well, telling the robot, hey, can you clean all 4 squares is actually not that good a set of instructions, because the robot really has no idea how to proceed. Instead, let's give it a set of instructions that it will just follow and over again until it reaches the end state. And so in this case, our pseudocode is always clean the current square that you're at. Then look at the possible moves that you can make. If only one of those squares has a dirty area, move towards that area and then repeat step 1 again, or go back to step 1. If there's more than one option, just pick one of those squares at random. And if there's no more dirty areas in front of us that we can see, then it means we're done cleaning all the squares. So if we go back to our robot here, step 1 is, well, let's clean our current square. And we did, so the square is now clean. Then we take a look to see where else we could possibly move to. And if we followed the steps, step 2 says check possible moves, and then step 3 says if there's more than one square with dirt on it, pick one at random. So we move to this square here. We clean this dirty square, and then once we're in this new square, we go back to step 1 and we repeat this process all over again. So now when we go back here, we go to step 1, which is clean the square, and then we take a look at what other squares there are. In this case, there's only one other possible square that we can move into that has dirt on it, so we move there, and then we repeat step 1 again. We clean the current square, then we look at what other squares are that have dirt in it. We see one more square, so then we go there, and then we clean up that square, and then we check for more squares again. At this point, when we check for more squares, we notice that there's no more possible squares, and at that point, we can say we're done. Okay, so even though the instructions seem to be quite short, by just having a robot follow these 4 steps over and over and over again, I'm actually able to have it complete this very complex process that it wouldn't have known how to do beforehand. But just by being kind of a little bit more thoughtful and giving it more easily ingestible instructions, what we've done is we've now created a repeatable process that the robot can always follow to kind of get the overall task done, without having to micromanage every single one of just without having to micromanage every decision from the get-go. We let it make its own. We let it make its own decisions, but we give it very strict rules on how to make those decisions. So moving on to JavaScript then, which just to kind of go back to our framework from day one, it's the brain or the nervous system of the website, right? Whereas HTML creates the raw elements and the CSS makes it look prettier, what JavaScript really does is it allows us to create more functionality, more interaction with the user or between the website. In effect, JavaScript is really what makes modern websites very powerful and very fun and very flexible, right? Is because it allows you to be able to engage with the site in ways that we couldn't do beforehand. So because we're doing 3 days on JavaScript, we're actually going to break it up into different sections. Today, we're going to talk mostly about the different kinds of data that can be used, that can be created and manipulated in JavaScript. We're talking about how to store this data for use later, and also how to make decisions based on certain conditions in the data. And then lastly, we'll talk about how to organize this code and data into meaningful units. So before talking about JavaScript itself in terms of how to build it, we'll just do a quick few minutes on the history of JavaScript. So JavaScript was created by Netscape in the 1990s, and the earliest version of it kind of really came out for consumer use in '95. Since then, JavaScript's gone through many iterations, which means that the JavaScript that we use today is not the JavaScript that Brendan used almost 25 years ago. JavaScript gets updated every couple of years with new functionalities and new features, which makes sense. As computing changes, as computer languages change, we also expect the tools that we use to change as well. And over the years, JavaScript changes has included new functionalities and also new security measures too. ECMAScript then becomes the standard implementation of JavaScript, and basically this is kind of when people say I'm using JavaScript, what they're really talking about is a version of JavaScript that's been I guess we'll say created or approved or overseen by this organization called ECMA, and they become the standard bearers for what JavaScript is. So they're the folks responsible for releasing new changes to the JavaScript language. JavaScript is one of the most popular languages out there right now, and it has been for a while. And the main reason why JavaScript is so popular is because JavaScript is one of the few languages that you can use across the entire stack. When we talk about the entire stack, what we really mean is if I think about a site like Facebook, there's multiple parts to it. There's the part that I as a user sees, which includes my newsfeed, my photos, my friends, and their homepages, etc. Then there's the parts of Facebook that I don't see, the databases of people, the relationships, the way it determines how to serve ads. All these information are things that the user doesn't see, but it's very imperative to how Facebook actually operates. So the part that we don't see is called the backend. And then lastly, there's a lot of database management too. So how do we store all the information that Facebook has? And so usually speaking, outside of JavaScript, most of the times if you want to build all 3 sections of a website, you actually need to use at least two or more different languages to do so. You might use one language for JavaScript, like JavaScript for the front end. You might use another language like Python for the back end, and you might use something else like SQL or Mongo for the database side. What JavaScript does then is it actually allows you to use JavaScript across the entire stack. That is, you can create all 3 parts of the web page or the web app with a single language. And so in that sense, it's actually very flexible. It allows you to work on an entire application from front to end without having to learn any additional languages. Sorry, and the reason why JavaScript the reason why the other people do choose to use other languages is because it's just like in human languages, right? Why do people choose to speak different languages? Because they're used to it, because there's performance differences, and ultimately because some languages are better at certain things than others, right? So we're not by any means saying JavaScript is the best language or is the fastest, because it's not, right? What we're really saying is when you're first starting to learn programming, it's a lot more important for us to learn the concepts of programming, which carry over across all languages, and we think that it'd be easier for you to kind of learn how the entire life cycle of application works by having to only learn one language without having to learn 2 languages in the same process. I'll say that when I went to full stack, I initially learned JavaScript, but eventually for my first job, I ended up doing Python. And so once you learn the concepts for one language, once you learn the basics for one language, the concepts usually carry over pretty nicely for other languages too. So as web development changes, we're moving more and more towards this idea of a single page application in the browser, which makes JavaScript even more powerful because of its ability to interact with users. And it's also really great for beginners because you don't need to learn multiple languages and switch between multiple languages to get the core functionalities. Okay, so on to the fun part, actual JavaScript. The very first bullet that we talked about today, we mentioned that JavaScript is really concerned with taking in data input, transforming it, and then giving you back output. Well, creating that raw data then becomes very important to us, right? Because we actually care a lot about the information that we're using within the ecosystem of JavaScript. So all of the information that we create and store in JavaScript has to be stored in something called data. And data can mean many things, but here when we talk about data, all we're really saying is pieces of information. And for us to understand how JavaScript, or at least how we talk about data in JavaScript, we have to make a distinction between two terms, values and variables. Essentially, what values are the underlying pieces of information, right? So if I have, in this case, if I have a number called 50, oh, sorry, let me just move this screen down really quick. Okay, so in this case, if I have a number called 50, well, the value of it is just 50. If I have a string, which is a collection of characters called George, then the value is just George. And similarly, if I have a value called false, then the value of it is false. Okay, so the value is the underlying value. It's a little bit of a tautology, and for that I apologize. But the point is, what I'm trying to make here is just that the value is actually what the actual thing is computationally. But then usually in JavaScript, rather than just dealing with that directly, we actually put a placeholder on top of it. And that placeholder is called the variable. That is, we use the variable as a way to make a reference to the value. So rather than using 50 everywhere, we can actually create a variable called number of states, or num of states, and store the number 50 in that variable. Similarly, we can have a string called George, but rather than calling it George everywhere, we can store that in a variable called name. And so really, when we talk about the difference between values and variables, sorry, is someone messaging me right now, or? Okay, sorry, just make sure I didn't have a chat. Okay, sorry. So similarly, because of the way that we store these values inside these variables, what we can say is that whereas values are data types, or data that has a specific purpose and intrinsic value, of a variable then becomes an identifier, or simply a label for that value. Now JavaScript is a bit strict on the naming of variables, and so what that means is we can't have spaces in the name of the variable, and in fact variables has to begin with a letter, an underscore, or a dollar sign, and it can only contain numbers, underscores, letters, or dollar signs. And then finally, variables aren't case sensitive, and later on we'll talk about a little bit about what are some to-dos and not to-dos when it comes to naming variables. Oh, and one more thing. There are certain words in JavaScript that are part of the actual JavaScript language. And so there are certain words that we cannot use as variable names. Generally speaking, almost every word you can think of, you can use it as a variable name, but some you can't because they actually they have a pre-existing value inside JavaScript. And so in most code editors, when you do type out a word that already has a meaning in JavaScript, we call that a reserved keyword, and those words tend to show up in a different color. So here on the right-hand side, if I want to create three variables, and I want to assign them different values, I can use the var or the let keyword, and then I type out the name of the variable that I want to be, and then I use an equal sign to use it, which is an assignment operator. I'm assigning whatever value is to the right-hand side of the equal sign to the variable on the left-hand side. And so in the first line here, when I say var num of states equals 50, I'm essentially creating the variable var of states, sorry, num of states, and I'm assigning the value of 50 to that variable. Similarly, I'm creating the variable name on the next line, and I'm assigning it the value of George, and the same thing for the variable answer with the value of false. Okay, so once again, all we're really doing here is just creating values that creating variables and then giving those variables values. So here's a few examples of the data types that we're going to be talking about. And for this class, primarily, we're going to be talking about the things on the left-hand side. Today we're talking about mostly about things on the left-hand side. And we'll talk a little bit about objects and functions on the right-hand side next Tuesday. Okay, you don't need to memorize these because we're going to go through these one by one. But this is just kind of a quick snapshot of the traditional, what is traditionally considered JavaScript data types. Okay, so the first one we'll talk about is the number data type. Numbers, I think, are pretty straightforward. They look exactly how you think they will look based on what we learned in elementary school math. They can be used to perform arithmetic operations, and the most common ones are just add, subtract, multiply. Add, subtract, multiply, and divide. Pretty straightforward. In JavaScript with numbers, you can use negative numbers by just putting a dash in front of the number. You can use decimals by just writing 3.4 or 2.6. You can make the numbers really as big or as small as you want. There are limits to the size of the numbers, but it's not something that you would ever reach if you just use it on normal. I think it's several, like million trillion or something. But yeah, JavaScript numbers are very flexible because once again, there's no requirement on positive or negative or decimals. You just write it the way you normally would, and JavaScript takes care of the rest. Okay, so that's numbers. The next thing we'll talk about are the next data type we'll cover is our strings. Strings are essentially a series of characters that are either contained by single quotes or double quotes. So here on lines 1, 2 in the code block on the bottom, notice how we're creating two variables. One's called full stack and one's called academy. For the variable full stack, we give it the string value of full stack. It's in double quotes and the value is FULLSTACK. And then on line 2, the variable is academy and the value is academy, space ACADEMY in letters. One of the things that we can do with a string is something called concatenation, or adding two strings together. However, just make sure that we're aware that the adding here is the difference between the adding that we saw for numbers. When I add two numbers together, I get back one different number. Here, when I add two strings together, or when I concatenate two strings together, what JavaScript does is, and this is actually fairly intuitive, is it just takes those two strings, combines them into a single string. And so here on line 3, I've added full stack plus academy, and when I do that, I get back is a final string full stack space academy. The other thing that we should know about strings is that every string also has by default something called a .length property, which just tells you how many characters are in that particular string. So in the example above, if I do full stack .length, because full stack is a string, when I do full stack .length, I get back 9 because there are 9 characters in the string. Sorry, I should have stopped earlier for questions, but is everyone good right now? Cool. The next data type we'll talk about are booleans. Booleans are pretty simple. They're a binary data type, which means there's only two possible values. Either something is true or something is false. Normally when people think of computer science, they think of the zeros and ones, and that's pretty accurate, right? Because if you think about it, the simplest choice that we can always the simplest choice that we can have a computer make is between a 0 and a 1, right? There's only two possible values and they're very distinct. And so when we create something called a binary data type, in this case a true and a false, we're making a computer choose something very similar. We're having it choose between true or false. There is no middle ground. There is no maybe. And so whenever you see a computer trying to convert something into a binary, then you know that it's trying to reach one of two possible scenarios or one of two possible endpoints. Even though these look like strings, notice how there's no quotes around them. So that's how we know that these are Boolean values instead of strings. The last two data types that we'll kind of quickly mention, but not talk about too much, are nulls and undefineds. Undefineds are values that are created when we create a variable, but we don't give it a value just yet. The undefined basically acts as a placeholder saying this variable does exist, but we have not yet given it a value. Nulls, on the other hand, are more explicit. When we assign something a value of null, then by default that means we've looked at this variable and we've decided to give it no value. And so whereas you very rarely assign something a value of undefined, because undefined is more of a default parameter, nulls are always intentionally set, and that means someone looked at it, did some calculations, and decided that this variable should not have a value. Okay. Another data type that we're going to go over again really quickly. And like I said, for the next couple of data types, we're going to go through them really quickly. We're not talking about too much because we'll talk more about them next Tuesday. One is an array. An array an array is called an array in JavaScript, but in Python, the identical data structure is called a list. And I think that probably makes a little bit more intuitive sense. A list basically is a collection of different things, and when we think about arrays in JavaScript, we can think of it as just simply a collection of different things. The anatomy array is quite straightforward. We begin an array with an open bracket. We then have different values within the array. Each of the different values are separated by a comma. So in this case, this array has 4 values. The first value is a Boolean. Then we see a comma, which means we're on to the next value, which is the true as a string, followed by another comma, and then the value false as a Boolean, followed by another comma, followed by the number 22, and then we close the bracket. So basically, an array is determined by the open bracket and a closed bracket, and however many elements you want in the array, you can have as many as you want. You just got to separate each of the elements by a comma. Next up, we have an object. Objects are made up of a combination of properties and values, known as key value pairs, to store data. So objects are a little bit more complex, but one analogy that I think makes a lot of sense is people actually say that an object acts very much like a dictionary. And when I say an object is a collection of key value pairs, that's pretty much the same as saying a dictionary is a collection of words and their definitions, right? So the key maps to the value very much like how the word maps to a definition, right? When I go to a dictionary, I want to get the definition of a word, but I look up the definition by the word. Similarly, in an object, it contains a bunch of key and values. I want to get access to the values, but I look up the values by the keys. And so here, we started an object with an open curly brace, and then each key value pair basically is separated by the key and the value is separated by a colon. In this case, cattywampus is our property, and the value is this string askew array. And then if I want more than one key value pairs, then I just separate each key value pair with a comma. So in that way, an object in JavaScript looks very much like a dictionary, except instead of having words and their definitions separated by commas, or separated by colons, we have keys and their values separated by colons. And then last but not least, the last thing we'll talk about is a function. A function is a reusable chunk of code, and really I would consider to be the primary backbone of computer programming. What a function allows you to do is execute a fairly heavy or as complex as you want. It lets you execute a set of commands on a set of given values as many times as you want. And so what functions really do is they allow they eliminate the need for us to write the same code over and over again, because we can just create one function or one set of processes or steps we want some data to follow or take, and then we just repeat that over and over and over again. So think of a function as very much like a recipe, right? It tells us what we need to give in, and then it tells us what it wants to do each and every time. And so in this case, on the top side of on the slide, we've made a function called bake cookies that takes in a flavor and a servings. Then it executes all of these directions. On the bottom there, we have two more smaller code snippets. And so once we write so here on the top half, all we're doing is creating or defining the instructions. And then on the bottom half is where we actually run or invoke these instructions. So here I'm actually invoking baked cookies and I'm passing in the different values. That's the same as me actually running the functions. One thing that I think tripped people up in the very beginning is that they think by creating a function, you're also running it. But in this case, if I don't have the bottom two snippets of code, then I'm not running the code. All I'm doing is creating, right? It's like me buying a car but not driving it. Like, just by creating it doesn't mean I'm going to run it. The only way to run a code in JavaScript is with the name of the function followed by an open and closed parentheses, which is what we call invoking a function. Okay, so be very clear whenever you see a function. Just because you see a function being made doesn't mean that it's being run. And in fact, you should actually double check to make sure you can see where on the page the code is being run, or sorry, where the function is being run. Okay. And then last but not least, because we've done this for every other language so far, we also want you to see how to make comments in JavaScript. JavaScript comments are even simpler than the other ones because you don't need to close off the comments for single line comments. You can just write // and that will make everything from there until the end of the line a comment. So we can put that on its own line, or we can put it at the end of an existing line of code. However, if you want to do a multi-line line of code, it actually looks very similar to the comment that we saw in CSS, in that it's just a backslash asterisk to start the comment, and then we end the comment with an asterisk backslash. And so that's pretty much it for today. On the workshop, we're going to be dealing with primarily the first 4 sections of the JavaScript section. So that's going to be the